What if your thoughts could control a computer? No keyboard, no voice, no movement at all, just thinking, and something happens. It sounds impossible, but real people are already doing this using something called a brain-computer interface. Imagine being fully conscious, able to think clearly, understand everything around you, but you can't move, you can't speak. For many people with paralysis, this is reality. For years, there was no way out, until scientists tried something radical. They implanted a tiny device directly into the brain and asked a simple question: what if we could read intention instead of movement? So they asked the patient to imagine typing, not moving their fingers, just imagining it. And then, letters started appearing on a screen. So what exactly is a brain-computer interface? A brain-computer interface is a system that creates a direct communication pathway between the brain and an external device, like a computer, a robotic arm, or software. Normally, your brain sends signals to your muscles, and your muscles carry out the action. But a brain-computer interface skips the muscles entirely. It connects your brain directly to technology. Inside your brain are billions of neurons. They communicate using tiny electrical impulses. Every thought, every intention, every imagined movement creates a unique pattern of these signals. A brain-computer interface captures those patterns using electrodes, either placed on the scalp or implanted directly into the brain. Then comes the most important part: decoding. Advanced algorithms, often powered by artificial intelligence, analyze those signals and figure out what they mean. For example, this pattern might mean move left. Another pattern might mean click. Another could represent a specific letter. Finally, the system sends that decoded signal to a device. So the full loop becomes thought, brain signal, computer interpretation, action. No muscles required. What makes this powerful is that even if the body can't move, the brain is still producing those signals. And now, we can use them. In a clinical study, researchers implanted electrodes into the part of the brain responsible for hand movement. Instead of asking the patient to move, they asked them to imagine writing letters. Each letter creates a slightly different pattern of brain activity. The system learned to recognize those patterns. So when the patient imagined writing a word, the brain-computer interface translated those signals into text on a screen. At first it was slow, but after training, the patient reached speeds of dozens of words per minute, close to normal typing. A person who couldn't move was suddenly able to communicate again. In another experiment, a participant with paralysis was connected to a robotic arm through a brain-computer interface. They couldn't move their real arm, but when they thought about moving it, thinking about grabbing, the hand closed. Thinking about reaching, the arm extended. Over time, they were able to pick up objects, move them with precision, even feed themselves. And here's the most fascinating part. The brain began to adapt. It started treating the robotic arm almost like it was part of the body. This shows that the brain isn't fixed. It can learn to control entirely new systems. This technology isn't just impressive, it's life-changing. Brain-computer interfaces are helping people by communicate after losing speech, regain control over their environment, restore independence. And this is just the beginning. Researchers are working on using brain-computer interfaces to turn thoughts into speech, restore movement after injury, treat neurological conditions. We're not just building machines, we're reconnecting people to the world. Now imagine where this leads. Right now, you use your hands and voice to interact with technology. In the future, you might use pure thought. Brain-computer interfaces could allow you to send messages instantly, without typing or speaking, control multiple devices at once, like your environment responding to your thoughts, interact with artificial intelligence directly, almost like thinking to an assistant inside your mind. Scientists are also developing systems that convert brain activity directly into speech. So instead of talking, your thoughts are turned into a real voice in real time. Someone who hasn't spoken in years could have a conversation again. Now imagine learning. Instead of repeating something over and over, a brain-computer interface could guide your brain into the correct activity patterns, helping you learn faster, almost like accelerating practice inside your brain. There's also the idea of expanding human senses. With brain-computer interfaces, researchers are experimenting with detecting signals humans normally can't perceive, receiving data as a new kind of sense, experiencing entirely new forms of input, not just restoring ability, but expanding what it means to be human. And then there's the most radical idea, a direct connection between the brain and the internet. No screens, no typing, just accessing information instantly. At that point, technology isn't something you use. It becomes something you're connected to. And the line between human intelligence and artificial intelligence starts to disappear. But this raises serious questions. If a brain-computer interface can read your brain, how much can it understand? Could thoughts become data? Could they be stored or even hacked? And if signals can be sent into the brain, who controls that? This isn't just technology, it's access to the human mind itself. We're entering a world where your brain is no longer limited to your body, where thinking is enough. And the real question isn't if this will change humanity, it's how far we're willing to go.